Hello everyone, I'm Alfian and today we are going to solve the HackerRank challenge on the data structure section called the tree, head of a binary tree. And for this example, we have the public static integer expecting the output of integer, and the function name is height, takes one parameter called the root, which is in the form of class as described right here, as the class node with the property of data, which is the node for itself, and then the live property, which is another node, and the node 2, which is on the live property, and node 6 is on the write property of from the node 4. And we are working with Java 7 as our language. If you want to use something else other than Java 7, then go ahead, I encourage you to do so. And the description says the height of a binary tree is the number of edges between the tree's root and its furthest leaf. For example, the following binary tree is of height 2. We have the node 4 right here, 2 and 3. But if you notice, from the left to right branches, from the leftmost to the rightmost, we have 1, 2, 3, 1, 2, 3, 1, 2, 3, and also 1, 2, 3. It's all on the balance height. We have all three height, but then this, for example, right here, the following binary tree is of height 2. So we need to get around this to find the exact answer of the height 2. So it's either this root node is not being counted, or a single node is not being counted at all. And for this function description says right here, complete the get height or height function in the editor. It must return the height of a binary tree as an integer. The get height or height as the following parameters, which is the root as we described earlier. And the note right here that we need to consider, the height of a binary tree with a single node is taken as 0. So do take note of single node is going to be taken as the 0 number. And the input format right here, we have the first line contains integer and the number of nodes in the tree, and next line contains n specified integer where the number of the integer denotes the node of the i.data, which is the data from the certain node. And for the example test case right here, we have the 3 to 1, 3, 5, 4, and then 3, 5, 6, 7. But we need to find the farthest one or the longest one from the tree chain, which is on the branch 3, 5, 6, and 7 on the leftmost, not on the leftmost, but on the rightmost branch. So we have 4 nodes, but it is counted as 3. And yes, the sample output is on 3. And the explanation right here, we have the longest road to leaf path is shown below, which is on the right highlighter. And there are 4 nodes in this path that are connected by 3 edges, meaning our binary tree height is 3. Okay, so let's solve this out by calling the recursion function, which is calling the function itself in the height, calling the root dot left. That way we are calling on the left side of the node 3 array, which is on 2, and then calling again with the height root dot right, calling both nodes 2 and 5, and then we need to compare those two to see which one has the max value. We can simply use a return statement, return statement, and then 1 plus the Math.max, and Math.max will compare both nodes, subnodes, to see which one from the branches are the longest one. And for the return runner here, it is supposed to be returning the node itself counted as 1 with the counting with the branches from the left and right property. So we need to count 1 because it's supposed to be counted, and using the Math.max and counting both left and right, both on in the front of the height function call of the root.left and the root.left, we need to use, I'm using the Alt Shift and arrow down to use a multi-line typing mode, and we can declare the integer expecting the variable as the integer, and we can call this left and equals in the height root.left, and for the right part we need to type right. And on the Math.max method, we need to pass in the left and right parameter to see which one has the highest value between one and another, to see which one is nominated as the highest value, using passing the parameter as the left and right. If the right value or the variable has the higher integer number than the left, then right will be returned as the Math.max right here, and return it with the +1, which is the counted as the node itself. But we need to declare an edge case to see if the root is equals to null, which is the function itself. If it is null, we need to add an edge case. Let's say on the node 2 right here, we have the left property of 1 and we have right property of null, and we don't want to count the null, then of course we need to return 0 like this, and then 0 will not be counted as the calculation of 1, since 1 has the value of 1. And let me draw this for a moment using the right highlighter. We have the right property of null from the node 2 right here, and 1 should be returning 1 right here, and with the null right here we are returning 0, and as they go up, 1 and 0 will be nominated. 1 will be nominated as the Math.max. 1 is going to be nominated, and then +1 again because on the node 2 itself, and this part should be 2, and on the right side it should be 3, and then we need to compare both 2 and 3 to see which one has the highest value, which is 3 right here, and 3 will go up, gets nominated, and 3 plus 1, which is from the return 1 right here from the node 3 itself on the parent root, on the parent node, and we got the value of 4. But we need to somehow return this as the 3 instead of 4. So if we happen to run this code, and of course we will get an incorrect answer. We have the output of 4 and the expected output should be 3, and we have output 1 and the expected output should be 0, and we have missed one integer. So how do we solve this? If you still remember about processing the null value from the node 1 right here on the subtree, we have left and right property of null, then we are returning 0 from the edge case, and as they go up, they get compared with the Math.max, then it will return 0 and then +1 right here, and then 1 plus 0, and we go up again and we got 1 plus 0 and then +1 again, because on the second +1, which is the node 2 right here, and we got 2 as the answer, and then go up again. Since 3 on the right side is being nominated, then this one is going to be eliminated. Then we need to convert the 4 into 3 is by using the -1 if it is null. Why? It's because as we traverse over the node, it is inevitable that we will always check for the left and right node, even if it's null. On the node 4 right here we have the null, and node 1 right here we have null, and the node 7 right here we have null. Since we are using the recursion, it will iterate through the null node to check if it is null or not. If it is null, then we need to use -1. Then on every branches right here, we cannot evade the -1 from the null node checking. On every branch, we will get -1 anyway, even if the parent branch is not null, which is on the 7 right here, on the 4 right here, and on the 1 right here, denoting that it is the end of the branch or end of the line of the node chain. Then eventually we will get -1, and then we will get 0 as our answer from the end of the line. And on the 6 right here we have answer 1, on the 5 right here we have answer of 2, and on the node 2 right here, since 1 and 2 already chain, then we got the 1 as the nominated, and 1 and 2 is being compared between those two, and 2 will be will win and going up, and 2 will be added by 1, and we got the answer of 3. So basically, on the end of the node chain, which is on the node 1 right here, node 4 and node 7 right here, we will get 0 as the answer, because checking the 7 itself, we have the 1 as the value returning 1. But then on the Math.max, we have left and right property, which is both null, and we have both -1. And since Math.max comparing those two, then -1 will be returned anyway. So since -1 will be returned anyway from both of the null nodes from the left and right, then 1 is going to be subtracted by the -1, or in longer answer, 1 plus -1. So we will get 0 as our end of the node chain. So let's change this as the -1, and let's run our code again to see if it works. And congratulations, we have the correct answer. Let's see if submitting the code also does the same thing. Submitting code again. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section. Or if you have any better solutions regarding this challenge, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day, and I will see you in the next video. Goodbye.